So, yeah, CaPerl, which is capabilities in Perl, hence the name. Okay, so, okay. Oh, I should warn you, by the way, that this is a new package that I've never used before, and I got kind of bored on the plane, so if I got a little carried away with transitions and things, I apologize in advance. Okay, so I'm going to talk about why you want to do this stuff. I'm going to tell you what capabilities are, why they're good, give you a bit of history, talk about capability programming languages, and then I'm going to talk about CaPerl. Hopefully I'm not going to run out of time in the process, because this was designed to be a longer talk in the first place. Okay, so the first thing is that we like to collaborate, and collaboration means that we want to share code as well as share data. But of course, sharing code is dangerous, as we know, because it can do bad things to you. But what I would like in a perfect world is to be able to accept a script that I've never seen before, have no idea what it does, and run it without caring about any dangers it might present to me. The usual way that people do this is they use sandboxes or jails, or that kind of stuff. And what those do is they theoretically confine what the code does by restricting it to a certain area of your machine, read and write certain files, open certain sockets, and all that kind of thing. But they tend to be either too open or not open enough. If you've ever tried to do cunning JavaScript stuff, you'll have come across the problem that you want to do some networking things, and the sandbox says, no, you can't do networking things like that. You've got to only connect to the host you came from, not some other host, or all that kind of stuff. So you have to ask the user to be kind and put you into the completely open sandbox, which is really not a very good idea. And if you wanted to really be safe, you probably ought to tailor the sandbox to each script that you're running. Understand what you think its purpose is, make a sandbox that does exactly what is required to restrict it to that single purpose. But that is really ultra tedious, so there's got to be a better way, and I think there is, and the way that I think is better is capabilities. So, what are capabilities? Well, it's a word that gets used a lot. They're not POSIX capabilities, and they're not Java capabilities. They're, well, it's kind of difficult to say in general terms exactly what they are, but they're these opaque thingies that represent the ability to do something. So they encapsulate just that one thing and nothing else. So here's some examples of capabilities. Read some particular file, write some particular file, talk on a particular socket, put money into my bank account, take money out of my bank account. To put money into my bank account, I'm quite happy to give to anybody, but I don't want it to give you the ability to take money out in the process. So that's why they've got to be opaque, because you've got to not be able to look inside it, find out what my bank account is, and do other shit to it. So why are capabilities good? Well, you can choose in the environment exactly what the visiting code can do by giving it exactly the set of capabilities that you want it to use. You can invent new capabilities at any time by just writing code that implements one of these opaque thingies that does the exact thing that you want it to do, and you can hand that to the code that you want to run it. One of the things that the capability crowd always go on about is designation is authorization, which is quite unlike the standard sandbox scheme. The idea being that if a user says, I want the script to write this file, then he's done. He's created a capability that allows the script to write that file, and that's all the authorization it needs, and it can't write any other file as a result of doing that. The other thing that you can do is you can partition within your code. So you can have modules that have particular purposes, and you can be sure that they only do the particular thing that they're supposed to do because they only have the capabilities to do the particular thing that they're supposed to do, because you only pass them the capabilities to do those particular things. So compare that to the traditional approach. In the traditional approach, it's very hard to say, with a standard permissions-based system, allow the program to write the file the user chose, and don't allow them to write any other file. Because the only way you could do that is to actually create a sandbox that allows that particular thing. And that, as I said earlier, is tedious. And you end up doing everything twice. First of all, you say, it's okay to do X. And then you say, please do X. And in fact, in practice, you don't even do that. You do it 3 times. And you do it backwards. You say, please do X. The sandbox says, no, you're not allowed to do X. And then you go, damn. And you go and fix the sandbox and say, it's okay to do X. And then you say, please do X again. Or you don't do it at all because it's too boring. So, if capabilities are so great, why aren't we all using them? Well, there's a kind of bit of history here. Capabilities were invented in the 60s, or in fact, maybe even earlier. Tyler probably knows, actually. Do you know Tyler? 67, okay, so I was right. They were implemented in hardware in 1970 at Cambridge University, and that's a picture in the background of CaP, the original machine that did capabilities. And it was kind of slow and expensive and really hard to program. Also at the same time, the academics were deciding that capabilities actually were really just ACLs in disguise. And they were saying, well, since they're ACLs in disguise, why would you bother to use them? Why not just use ACLs? This is kind of like saying all programming languages are Turing machines, so we should only have one programming language, right? Even if it was true, which I don't really believe it is true. I'm not going to get into why it isn't true, because that's kind of weird academic theory shit that I can't be bothered with, but it isn't true. They're certainly much more convenient to use than ACLs in a lot of circumstances. So, okay, so hardware was kind of abandoned. Though actually, incidentally, the AS400 is allegedly a capability machine underneath, but it's the capabilities are not exposed to the user. They're hidden down in the operating system. And by the time you get up to user level, it's just an ACL thing again. So there were some operating systems that use capabilities. The first one that I know of was KeyCuts. This runs on IBM 360s. It's a proprietary commercial thing. I believe it costs an arm and a leg. You can't get hold of it unless you have an IBM 360 for starters. Yeah, it's expensive. So this guy called John Shapiro wrote this thing called EROS. EROS stands for Extremely Reliable Operating System. He thought the capabilities were about reliability when he started and not about security. But he changed his mind later. But that project went on for a long time. It runs on PCs, so it's pretty cool. It's open source, but it's not finished. Recently, he abandoned EROS. I'm not sure why. He just didn't like the way it looked inside, I guess, and decided that he had to start again and started writing this thing called Kyetos. But of course, you can't write a new operating system without designing a new programming language first. That's obvious. So he's now busy writing a new programming language instead of a new operating system called BitC, which is kind of nuts, if you ask me, but it makes him happy. EROS got taken over and is now called CaPerl. You can get it on SourceForge. I don't know if it's going anywhere, but it's there if you want to play with it. And it does even run. It doesn't do anything useful, but it runs. There is this other one that I have come across called Amoeba. That's only free if you're academic, and because of course, I'm only interested in this stuff if it's free software, in case you hadn't guessed. And it actually looks kind of sweet, but it's one of those ones where they say, if you would like a commercial license, then get in touch with us, and that's a sure sign that what they mean is give us an amazing amount of money. So none of these things are really usable at the moment, and none of them look like they're going to be usable at any near stage. And I'd like stuff to be usable. Another thing about capabilities is this thing, the Granovetter diagram. Granovetter was a sociologist. He had this idea that you could only ever meet somebody by being introduced to that somebody by somebody else. I think he lived in a more gracious age than we do, because that's not how I meet people. I meet them in all sorts of strange ways. They send me email, I sit next to them on aeroplanes, and so on. And, you look at this diagram, what does it tell you? Does it tell you that security is available through capabilities? I don't think so, but these guys are nuts about it. And they think that it explains everything. I don't get it. So, summary of the history. Academics are nuts. And, yeah. So anyway, history lesson over. We'll move on to capability languages, which is what I'm really interested in here. So I'm going to talk about 4 things in this. The requirements for capabilities in a capability language, implementing them in standard languages. There are 3 options here, basically, once you've got the requirements. So implement them in a standard language, design the language around capabilities, or modify the language so that it supports capabilities better. So, here we go. First thing you need is an opaque thingy. So your capability has to be some kind of thing that can't be looked inside. So it can be an object in an object-oriented programming language, but it, like I say, you have to not be able to look inside. Or it could be a bound function, if any of you are familiar with that kind of thing, which is where you take a function and an object and you glom them together in some way, and then the glommed thing is that function call on that object. And again, you need to make it opaque so that you can't get the object out from inside the bound function. It can be a random number, which is a popular approach for distributed capability systems. So the number is something that you send over a network that represents that particular capability. Or it could be a pointer, and again, you have to be careful with a pointer to get the opacity that you need. Another feature of capabilities is they can't be forged. So you have to be unable to make up something that looks like a capability or is exactly the same as an existing capability. You should not be able to discover them, so you shouldn't be able to search around in the memory space or use introspection or whatever to find capabilities that you don't have. Authority should be confined to capabilities, and only trusted code should be able to create capabilities with new powers. And if you don't have the capability, you shouldn't be able to do anything that's interesting other than computation. So, implementing these in standard languages. Opacity is a problem because most standard languages do not provide opaque objects. Forgeability is a problem because most standard languages like to let you poke around and do introspection or looking inside RAM or any of that stuff. Confining authority is a problem because most standard programming languages have standard libraries that just let you open files, open sockets, generally do what you want. But the advantage of standard languages is that we already know which standard languages people like. So let's look at a few. C. No way. All the code has access to the whole of RAM. You've got no way to confine authority. You can just do what you like in C. You've got no way to prevent forgery. It really is a complete dead loss. C++, same as C. Python. Well, it has been suggested to me that you can use these things called proxies in Python. So a proxy in Python is a Python object that wraps another Python object. And the idea is that you can control who can call the wrapped object by having a security thingy that says, yeah, this guy can call that object, or no, that guy can't call that object. But the trouble with that is that you have to write a proxy for every single thing. You have to write the security function for each thing, and it's really very tedious. And you rely on restricted execution mode, which the Python guys are not very interested in and don't maintain. And when I was looking at this, restricted execution mode didn't work. So the security of these things was far from clear. Perl, which is actually the language that I'm going to be talking about later. Yeah, Perl, you can do anything in. I mean, everyone knows that. That's the whole point about Perl. You can load arbitrary binaries in Perl, which really is going to get in your way for doing this stuff. It's possible, because Perl is one of those self-modifying languages. It's possible that you could overload stuff in Perl and somehow enforce the opacity and the unforgeability and all that. But would we ever believe that that actually really worked? I don't think so. Small talk. There is apparently a thing called squeaky. I don't know if that actually works yet, but apparently that actually does capabilities in Smalltalk. But who uses Smalltalk? Not me. There's a bunch of others that people have suggested to me might do it. Ruby, Erlang, Haskell. I don't know. Ruby is kind of popular. Erlang and Haskell, very obscure. I don't know if you've ever tried to learn Haskell. I tried once. Oh yeah, you can write it? Could you teach me? Cool. Because I try to learn it from tutorials, and tutorials quickly get to the point where you cannot follow the tutorial unless you can already program Haskell. It's I did, I think, but this is your trouble. You see, you already knew how to program Haskell when you read it, I bet. Yeah, Haskell's kind of interesting, but it's a strange language. It's a lazy evaluation language, and it's yeah, it's weird. Okay, so building the language around capabilities, there's obvious advantages to doing this. You can be absolutely sure that the language really does provide the properties you need to implement capabilities. You can design the language so that capabilities are easy to use. They're not awkward like they would be in a modified standard language, or sorry, in a standard language that you've somehow figured out how to do capabilities in. And you can make a language that actually is aimed at capabilities, and has exactly the right properties, the right syntax, so that capabilities fit neatly into it. But the trouble with new languages is that very few succeed. You can have a lot of fun writing them, hardly any take off. So, E is a language that was designed to do capabilities. It's actually a really cool language, but it has some very cute network stuff that it does. It does this deferred evaluation thing, so you can run methods on other machines in the network, but not expect the answer immediately. You can carry on executing, and at some point when the answer becomes critical, it will block until it arrives. It also does this neat stuff where it guarantees various ordering properties as you pass capabilities around between machines, so that you can actually understand what the execution is going to be, despite the fact it's distributed and asynchronous. It's quite cute. Here's an example of E. The syntax is kind of weird. I mean, you can see you've got arrows going different ways, you've got dots, you've got this funny when thing, which I suspect, I ought to know, but I suspect means that the stuff inside the when is going to get executed at some random moment later. Yeah, but like I say, it's cute. But it's written by academic language nerds, and it has esoteric syntax, which actually I have to admit they've been gradually fixing. It's getting less esoteric. But it changes its syntax monthly, which is kind of a problem. And it's based on Java, which means that there's a limited number of places you can run it. There are others, maybe. Mozart. I've heard that that's a capability language. I've never seen it. So, next approach, modifying existing languages. So, the nice thing about modifying this existing languages is that you're reducing the risk of choosing a language that people aren't going to adopt, because obviously you start with one that they do use. There's a nice shallow learning curve because people already know how to use that language. In general, that's what I would like to do. But it's not always possible. You have to have a language that at least vaguely admits the possibility of having capabilities put in it. So the first one I tried, I've actually done this a couple of times now. The first one I tried was Python. And my idea was to modify the interpreter so that it would enforce these capability properties. The trouble is that when you get inside Python, the interpreter actually really has no idea what is going on. It's compiled away all of the interesting structure in the Python program and has left you with really nothing that tells you who's calling what, which objects belong to what objects. It's effectively turned into this kind of assembler. You've really lost the ability to do anything sensible down in the interpreter level. And the other problem is the Python developers are not interested in capabilities. So even if you succeed in this, you're going to have a horrible maintenance problem because you're going to have to do it your own thing. The Python guys sound like they're not going to adopt it. And as I mentioned earlier, restricted execution mode, which is vital to this, is broken and is not maintained. I should just say about that. I was actually funded to do that work on Python, and it came out so horribly badly that despite many weeks of effort on it, I didn't take the money in the end. So Perl. One day I had this idea, which was to use the language itself to enforce the capability discipline, rather than trying to modify the underlying interpreter to change the language, to compile basically some Perl-like language into Perl that enforced these capabilities. So that's what CaPerl is, finally getting onto the meat. So I'm going to talk about what CaPerl is, what the modifications I made to the language were, about this thing called taming, which is about how you use existing code within a capability language, how you use CaPerl, how it's implemented, and a few examples of how it runs, if I have time, that is. Okay, so as I said, CaPerl turns Perl into a capability language. It compiles in standard Perl. The compiler is written in Perl, and YAP, which is yet another Perl parser, I think, along the lines of YAC, which is yet another compiler. Or is it yet another parser? I don't know. But anyway, it's one of these things that takes LR1 and converts it into Perl. So yeah, you get a lot of Perl in this. Okay, so what do we do to the language? The first thing we do is we introduce the idea of trusted and untrusted code. Trusted code is the code that we wrote, that we run, that creates capabilities and that we believe is safe. And untrusted code is the code that some other guy gave us, that we have no idea what it does, but we want to run it anyway. So here's the first modification. You have to be a Perl programmer to understand this, probably. Maybe not. So you can declare a sub to be public in Perl. Oh, I should add that this is object-oriented Perl, so it's all packages and new and bless and all that good stuff. So a public sub, anyone can call. Pretty obvious. You can have a trusted sub, and only trusted code or code in the same module as a trusted sub can call it. And you can just have a plain sub, which would be private in some other languages, which can only be called from the module that it's declared in. The second set of modifications around the use. So use module, the module must have been compiled by CaPerl in order for you to be able to use it. You can do a use untrusted module, in which case the module doesn't have to have been compiled by CaPerl, but only trusted code can actually run use untrusted. You got blessing, which is the next thing. Only trusted code can declare which class an object is blessed in. Untrusted code can only do that, bless $self, which will bless in the module that it's defined in. So that prevents forging. So trusted code can do almost all standard Perl stuff. Almost all. But it can only look inside objects that belong to the same module, or just straight hashes. You don't have to, things that aren't blessed are not protected. It can import any module using use untrusted if it needs to. It can call any function in the same module, which indeed any code can do, and it can call both public and trusted functions in other modules. Untrusted code can't call plain non-object oriented functions. So it can't call things like open or opendir or system or exec or any of those things. It can only look inside objects belonging to the same module. Same deal as trusted code. It can only import trusted modules that have been compiled with CaPerl. It can call any function in the same module, and it can only call public functions in other modules. So, taming. Taming is about taking existing libraries and wrapping them in a capability library. It's pretty obvious that only trusted code can tame, because only trusted code can load the other library in the first place. But of course, the cool thing about taming is that then you can use CPAN. And you have a huge wealth of existing libraries available to you. But you do actually have to think to do taming. Okay, implementation of CaPerl. It's ordinary standard compiler stuff. You use the app to create a parse tree with some Perl added to it, and then you run through the parse tree and spit out standard Perl. That's just a simple recursive process. It doesn't have to do anything clever. A little bit of context is passed down the tree as it recurses, but nothing really sophisticated. And it turns out that the compiler is astonishingly small, actually. I think it's under 1,500 lines of code. And almost all of it is completely trivial code, where it's just, I parsed this thing, I spit out exactly the same thing I parsed. Most of the restrictions are actually in what the parser will allow you to compile in the first place. So compiling, you say CaPerl module.tm. TM is for trusted, UM is for untrusted. You can also just pass a flag to say whether it's trusted or untrusted. It outputs Perl, which you just run in the normal way using the Perl interpreter with the CaPerl libraries on the lib path. So that, well, even that's not strictly necessary. If you don't use the CaPerl libraries, which you don't have to, then they don't have to be on the path. And modules are completely independent of each other, so you can just compile them as independent units. There's no interrelationship between them, so you don't have to do anything cunning about dependencies. Right, the innards of the CaPerl code. So there are 5 chunks to this. There's marking the code that is CaPerl compiled. There's restricting function calls, there's making objects opaque, loading appropriate modules, and control of function calls. Confusing. I don't know why I said that, as well as restricting function calls. It'll probably come back to me when I get there. So, marking CaPerl code. When you say package module, it becomes that. Package module, and $module, : CaPerl code equals 1. So it just sets a global within that module that says this is CaPerl code. You'll see why later. If it's trusted, it also sets that, CaPerl trusted. Restricting function calls. If you try and call a function on an object, it turns into this kind of crufty thing. So what's going on there is declaring a couple of local variables, sets the first one to be the object that you're about to call the function on. And the reason it does that is because $obj could be some more complex expression, and you only want to execute it once, but you've got to use it twice. So it executes it at this point. Once it's executed it, it takes ref to it, ref being Perl for tell me which module this belongs to. And then it checks whether that module has actually got the CaPerl code marker in it, and dies if it hasn't. So that's just preventing you from calling functions on things that aren't capabilities. The other side of this is the declaration of a function. When you say subfunc, which is a private one, if you remember, it finds out who called, which is what this caller thing does, and checks whether the caller is the same module. If the caller is not the same module, it dies. When you declare a trusted sub, you get a similar thing. It has to be called from the same module or from trusted code, which is what this CaPerl trusted global was for. So that's just, again, you get the caller, you check whether it's the same module, or whether the module that called you was trusted. Public subs just become plain old subs in Perl, do no checking at all. Okay, making objects opaque. If you're going to look inside an object, you've got to actually own that object. So again, it does a pretty messy expansion. Again, it evaluates the object, takes a ref to it, checks whether the ref belongs to the module or is a hash, and dies if it isn't. And then it just carries on. If it hasn't died at that point, it will just carry on and do ordinary Perl extraction of the inside of the object. When you use a module, it checks whether it's CaPerl code. So you do use some module, check whether that global is set in that module, and die if it isn't. If you use an untrusted module, which again, remember, only trusted code can use an untrusted module, and that's enforced by the compiler, then that just becomes use module in the usual way. Okay, I'm actually going kind of fast here, I'm surprised. Some examples of CaPerl. I just got two here. One is to run an untrusted CGI, and the other one is an example of how you write taming. In this case for just a built-in function, opendir. So first of all, untrusted CGIs. So this is the wrapper. This runs under Apache or something like that. And it's compiled as trusted code. So it can do the use untrusted. It loads the standard CPAN CGI library. It loads a little wrapper, which is a CaPerl module, trusted module. CGI carp is just because I wanted the error messages to actually go into the error file. That's not particularly interesting. And POSIX is for an error number that is used later on. You create a new CGI object, you pass it to the CGI wrapper, and you get your CGI capability. You then just do the ordinary printing of the header to say you're outputting HTML, which means, of course, that the the untrusted CGI can only output HTML and not some other kind of object. If you wanted to extend that, obviously you really easily could, but for this example, that's the way it works. You get the environment from the web server. Oh yeah, this is slightly messy. This is purely because of the limitation of the compiler at the moment. It only understands reference to hashes and not plain hashes. So you have to take a reference to the environment hash before you can look inside it. Gets the path, which is the way you actually call this is the URL would be this wrapper / the name of the untrusted code that you want to run. So the path info actually tells you what the untrusted CGI is called. The base is something that's just set in the configuration. There's a directory containing all of the untrusted CGIs, and it croaks if you did anything naughty, like passing anything other than letters, numbers, and underscores as the untrusted CGI, i.e. doing things like dots is not allowed. Next chunk. What is this? Oh yeah, so the idea behind these CGIs is that they have access to a directory which they can do whatever they want in. They can create files, they can read files and write files in that directory, but they can go nowhere else. So that allows you to do CGIs that have some kind of long-term storage. This is to demonstrate the idea that you can safely run this untrusted CGI but still give it access to resources on your machine. So the directory here is one per CGI, and it's just named the same thing as the CGI is. It creates the directory if it doesn't exist and dies if anything weird happens there. Then it uses this CaPRW directory, which is one of the CaPerl libraries which anybody could write. It's nothing special, but it implements this capability for a directory in which you can scan the directory, open files, create files, read files, write files. It then does this slightly weird thing, which is to avoid the Perl picking up the wrong thing because it's on the lib path. So it just directly reads in the untrusted code and evaluates it. And then finally, it creates a new instance of the untrusted code and calls a function in it, which is the go function. And it passes it these two capabilities. One capability is the CGI, so it can do output to the user and get input from forms and stuff like that. And the other capability is the directory capability that allows it to do reading and writing, so it has its long-term storage ability. And that's all there is to it. I guess I should have shown you an example of a CGI that you run underneath this, and I forgot. Okay, taming. So this is a package that wraps opendir. It uses the untrusted package symbol, which is required to get a handle so that you can do the opendir. And this is just really basic, standard Perl, object-oriented Perl. You create a new instance of the class with nothing in it, you bless it, you put the name of the directory you want to open into it, and you return it. And yeah, nothing much to say about that. Destroy, which is private so nobody else can call it, but not for any particularly good reason, just because there's no reason for it to be anything other than private. Closes the directory, and if it's open. Opendir opens the directory that you told it in the first place. So note, by the way, that the new is trusted, so only trusted code can call new. So you can't create one of these capabilities unless you're trusted code. But opendir is public, but it's obviously restricted to the directory that the trusted code assigned to this wrapper. then you just wrap the other functions, read dir and close dir. There's nothing interesting there, but you can see they're trivial. The point being that these are really easy to write. Yeah, so there you go, that's a wrapper. And actually I'm kind of at the end here. So what have I not done in this? Not very much. This is not a complete, it doesn't understand all of Perl yet, but it's not very far off. So it's slightly awkward to use in places, but it's mostly complete. I'm still not quite sure about the trusted-untrusted divide, whether you shouldn't maybe have a third kind that can do any Perl stuff and isn't restricted at all, because I found that occasionally I have to write Perl and then pretend that it's being compiled by CaPerl by putting the constants in it. But that doesn't stop it from working, it just means it's more awkward to use. And loading in modules maybe should be 3 capabilities instead of this use untrusted stuff. But I haven't quite figured out how to make that work neatly. So, a couple of conclusions. Capabilities are not as hard to implement as you might think, or maybe they are after you heard how I did that. Capabilities are not as hard to use as you might think. Using pre-compilation to add capabilities to existing languages is actually pretty easy and appears to work. I mean, this is a proof of concept, but it does appear to work. And capabilities have powerful security properties. At some point, this stuff's going to be available there, caperl.links.org. I haven't put it up yet. It'll be a couple of weeks because I'm away for a couple of weeks. And so that's it. Anybody got any questions? Yeah?
So could you take the same approach
To Python?
Yeah.
I believe you could, yeah. I'm less familiar with Python, which is why I did this for Perl initially rather than Python. Really, all you need in the language to do this, as far as I can work out, is the ability to figure out who called you, pretty much. And then, I mean, the rest is pretty certain to be available in any language. But if you can figure out who called you, then you can, two things. Sorry, you need the ability to figure out who called you, and you need to be able to tell who an object belongs to. I'm not certain whether you can do those things in Python, but if you can, then you should be able to do this. And if you can't do those things in Python, I imagine it wouldn't be too hard to add them. Anyone else? Yeah. I haven't tried using them. This actually was a really quick project. It only took me about 7 days to write this compiler, and I haven't had a huge amount of time to do complicated things with it. I think the problem with DBIs would, if you want to give a piece of code and access to a database, and then you don't care what it does within that database, then wrapping DBIs would be easy. But I presume that the point of wrapping DBIs would be to have some control over what was going on within the database, and the issue there is that you're ultimately going to be passing SQL to the DBI, and SQL is effectively a Turing-complete language, and so you would have to parse the SQL or turn the SQL itself into a capability language, or do some kind of abstraction so that you weren't actually parsing SQL, or passing SQL rather, into the DBI, but you were specifying what you wanted to do the DBI to do in some more abstract way that you could then control with capabilities. Yeah.
Two things. For example, you're using eval on the untrusted code.
Yeah.
That's a wrap form, something that's going through the pre-processing system.
No, because the untrusted code has been compiled into standard Perl. So the eval is just plain Perl eval.
But you don't know what file name is that's getting eval until that statement is run. how do you, at what point does your process get run on that?
So the idea is if I had a really complete system for this, what would happen is the thing that accepted the untrusted CGI would put it in some known, would compile it and put the compiled result in some known place, and you would only run stuff in that known place. Well, it does only run stuff in that known place, right?
The other question was, you were using the flag, the trusted flag and CaPerl flag. What prevents a module from setting that, an untrusted module from setting that on itself? Like $1 set.
So I missed one of the things that untrusted modules can't do, and one of the things untrusted modules can't do. Well, actually, there are two things. One is they can't set globals, and the other is that they can't use colon, which prevents that. Sorry, before Tyler, the guy behind you.
His second question was the same as mine.
Okay. The other thing it does as well, actually, is it modifies variable names. So it adds a letter on the front of variable names to stop you from screwing around. Yeah, Tyler.
So given that it's only saved to run code that's already passed through your precompile,
Yeah.
I'm wondering why we still need at runtime check situation.
Because you can't do those checks at compile time. I don't think I understand that question.
So if I know the code is calling some method,
Yeah.
I'll check to see whether that method is a public method.
No, you don't check that at compile time. You only check, because you can't. It's too hard. Or maybe you can, but the way this works is you check it at runtime. Anybody else? Okay, I guess I'm done then. Thank you.